flow control and alt conditions, there may be only two phases, MMC and handshake packets. Okay, so first we'll see the general model of transaction. Okay, so we know that this normal flow, token, data, then handshake. Okay, look at here. Here we are going to consider in transaction. This is out transaction. In means what?
Host want to take data.
Right. Out means?
Host is giving data to device.
Right. So you consider this as a timing axis in this direction. Okay, so first host is sending MMC. Okay, MMC, it will tell that in the next time duration what are all the devices has to do its operations. Okay, so in that MMC it will tell all those channel time allocations, everything. Okay, and you can see here that this MMC will always be transmitted at 5 base signaling rate. Next, direction is equal to, direction bit will be set to 1. 1 means that is in, it is expecting data from host, device. Okay, next what will happen here? So this will happen at the time t is equal to 0. We'll consider in that way. Okay, after some time, that time specified here, at that time device has to send the data, right? So it will send the data. So it will start with the sequence number n plus 1, like that. It will keep on send its data. Okay, at last what host has to acknowledge for this data, right? It has received successfully, like that. It has to send that acknowledgement. Where it will send? It will send in the next MMC. This is called the bit vector device notification acknowledgement, right? This is for in transaction. Here you can see that MMC not received properly. So direct idle state. You have asked one question earlier. If MMC has not received properly, in that case what will happen, right? So here see, it will go to idle state and it will issue NAC, right? So here, yeah, this means what? NAC means what? Right, that's it. So this is all about this general model of this one. We have seen only in part, right? Here we have one more option, that is handshake. Handshake is equal to negative acknowledgement or stall. Okay, that means what? It has received this. It has received this MMC. It's having some problem, or it has not received this MMC properly. In that case, it will issue this, right? Then out transaction. If we come to out transaction, what will happen? Here direction bit is set to 1. Here direction bit will be set to 0. Next, in that device receive time, device has to receive that data. It will start to receive n plus 1, n plus 2, like that. At last, host will allocate some duration for device node handshake. During that time, it will send its handshake, right? First we'll see one example regarding streaming, and now the device will going to transmit. Look at here. First we know that we're going to receive MMC. In that MMC it will tell that at what time the device has to receive. So it will be ready in this slot. Okay, next, the stream of data one after another, it's coming here. So in this it is sending data of S0, and in this next MMC it is sending the next data S1, right? Okay, it's keep on sending its data. And one more thing, here device is transmitting, right? We are considering device transmit scenario. So who will going to give acknowledgement? The host has to give acknowledgement, right? So it is giving acknowledgement. In acknowledgement it sets that bit to 002, right? That means what? It is asking data source to send second data, like that. So we know that MMC followed by one time duration, that is known as transaction group N,
Asking
and this
for
is
the
known by
second data means first has been received.
right successfully.
Okay.
And here you can note the detailed explanation of what is happening in this time duration. Transaction 0. In transaction 0, yeah, it starts with MMC. That MMC, what it is sending, it has received 0 1, like that it is sending, and in the device data S0 device is using, and then in the next MMC again it is sending that one, the acknowledgement for first, and device is sending the next, like that it's keep on going. Host add the acknowledge information in the next MMC. That is what is the important point here. Okay, getting? Okay. Second example, end of transfer. How the end of transfer, how the device or host will come to know that this is the end of transfer. So it is keep on sending the data. At last here you look at here, end of list, blank device transmit channel time allocation. End of transfer is informed by using WX channel time allocation EOL and also next start time. Getting? So host is sending end of list, this the end of list channel time allocation. So this is indication for the end of transfer, right? Do you have any queries in this slide? Okay, we'll move to the next example. Next is short packet, data in transfer. For data in transfer, what is short packet? So you look at here, it starts with MMC again and it is sending data. If it is lost data, means how the device will inform it to the host. In that data packet we will have one flag, that flag will be set to 1. So this is the indication for the host that this is a lost packet from the device. Okay, so buffer space available, so buffer space is available. So next transaction on seeing the flag.
In which direction our data is moving in this diagram? Towards left or towards right?
I'm not getting your
Which direction we are showing that our data is moving? Towards right or left? Which MMC will be received first?
this one,
After that the data will come.
right?
So it's moving towards left. Means
Device
getting like
if you consider from the device point of view,
yeah.
device will receive this MMC first,
Okay.
then it has to respond with its data. Next some duration, device will second it will receive this